Hey, we're live. Welcome everybody to the weekly review video. I got to stop calling it a podcast. My name, as you know now, is Mr. Bray. Let's turn that down a little bit. It is currently Friday, September 19th, and this is for the week of looks like the 15th through the 19th. We're going to kind of hit the major topics here. I got a list of stuff to talk about. Some friendly reminders as we go through this, as always. Sorry, I'm just turning on my stylus. Down at the bottom here, you see if you got questions throughout the video, through the broadcast, if you're watching it live, you can send a tweet to @WindsorChem, or you can text to 607-205-8577, and I'll get your text message. It'll show up, and I can answer a question that you may have. Please keep them appropriate. Please keep them relevant. And please, either way you go, please include your name. If you don't include your name, I won't discuss your question. However, I will not use your name live. So let's get started. First off, welcome to Brayland. This was my first week back. It was so great to be here. It was awesome to meet you all. I think I have most of your names down, which is really exciting for me. And you're getting to see technology now at work, which is really exciting. We talked about getting to know me and how the course works, and that's all great. But we got into Unit 1 halfway through the week, and that's all about introduction to chemistry and how it works. And then we're going to get into classification of matter and its changes next week. But it started with math and algebra. Today you got back your pre-math assessment. Please, again, take that student reflection survey. The link's on Twitter, Facebook, and on the course webpage. But you got that back, and we're just seeing how you do with math, and we went through some algebra problems. Remember, let's see, all those sample problems that we did in the notes, the 2x equals 5, all that stuff, that's the math that you're going to see. I took a sample problem for every mathematical calculation we might see in the course, and we did those together. So if you can handle those problems, you're in good shape. Life is good. From there, we got into scientific notation. Some friendly reminders with scientific notation. When you're looking at a number in scientific notation, the first number has to be greater than or equal to 1 and less than 10. So you could have decimal numbers, you could have all sorts of crazy stuff, but the value of that number has to be greater than or equal to 1, but less than 10. Then you're going to have, the exponent, and the exponent told you how many places that you needed to move the decimal point. We're going to look at a couple examples here in a second. And the way I liked thinking about it is the sign of the exponent tells you what the number should be. If it's a positive exponent, that means you should have a big number, like bigger than 10. And like in terms of money, it would be a big amount of money. If it's a negative exponent, it's a small number, less than 1, like 0 point something. In other words, if it was an amount of money, it's a small amount of money. So with that, here, let's flip over and look at an example. There we go. So, good, you can see that, I hope. And if you can't see that, I'm really sorry. But with this problem, I want to write this number that's in scientific notation. I want to write it in standard notation, or expanded notation is another way they call it. So let's get the pen working here. You can see, again, my first number, it's between 1 and 10. It's greater than or equal to 1, greater than 1, less than 10. So I'm going to start with that number. Let's make this a little bit darker. I'm going to start with, not there, 5.748. Right, because that's what they gave me. Now, this exponent right here, the 8, that tells me I have to move my decimal point 8 places. And it's kind of a 50-50 shot, right? I could move it 8 places to the left, 1, 2, 3, 4, 5, 6, 7, 8, which would give me, let's see, that would be 0.0000005,748. That's one possibility. The other thing, I could move it 8 places. I don't know why I picked 8. 8 places to the right. And in that case, I'd get 1, 2, 3, 4, 5, 6, 7, 8. Fill in the zeros. That would give me 574800000. So if I put in commas, that looks to be 574,800,000 So which is the right answer? When I go back and look at my original number, here the exponent is positive. And positive means it's a big number. So when I'm thinking big numbers, that's your big number. So what all that means? 5.748 times 10 to the 8th would be the same as 574,800,000, right? Not too bad. Cool. Let's look at another example. Oh, that was my third example. Let's go back up and look at this example. So same deal. Oh, you know what? Let's go the other direction. Let's try this one. Let's put this into scientific notation, because some of you had a little bit of a trouble with that. Not too much, but a little bit. So I have to move the decimal point to make the number appear to be between 1 and 10. And if I move the decimal point to there, the number becomes 76584.836, and that's worse than I started. I started at 7,000. Now I'm at 76,000. That tells me I'm not going the right way. I have to go to the left. And if I go one spot to the left, that would make the number 765 point blah, 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 blah. That's not what I want. So I need to go one more spot. That would make it 76.5 blah, 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 blah. That's not between 1 and 10. I have to move it there. That gets me at 7.658 blah, 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 blah. Now, just to prove a point, if I went one step further, that would make it 0.7 blah, 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 blah. And that's not between 1 and 10. So that doesn't work. Let's just get rid of that. So I got to stop there. Excellent. Now, we'll get rid of all these dots. That could be confusing. So I'm going to have a time. Whoa. Nope. There we go. Whoop. Times 10 to the something. How many places did I move it? 1, 2, 3 places, right? Let's double check. 1, 2, 3. You got it. So it's going to be a 3. The question is it a positive 3 or a negative 3? Well, when I look at my original number, that's a big number. If that was an amount of money, that'd be a lot of money. It wouldn't be that much money. That'd be cool if I could magically make it more. But it'd be 7,000. That's a lot. So that means it's a big number. I'm going to leave this a positive exponent. So what that tells me in the end is that these two numbers are exactly the same. Right? 7,658 point blah, 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 blah is the same as 7.658 blah, 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 times 10 to the third. The way you could check, you could either try and go backwards, or if you were to enter this into your calculator, you should get your starting number. Not a bad deal. Let's try one more. Up here, we have 3.67 times 10 to the negative fifth. Okay, so we'll start with the number they gave me, 3.67. Now, I know I got to move it 5 places. Again, we could go 5 places to the left. 1, 2, 3, 4, 5. That would give me, if I fill in my zeros, I always lose track. 0, 0, 0, 0, 3, 6, 7. That would give me that. If I went 5 places the other direction, 1, 2, 3, 4, 5, put in 3 zeros, 3, 6, 7, 0, 0, 0. 367,000. So I know beyond a shadow of a doubt one of those two numbers is the answer. If we look back at the original number, it's a -5. So that means I need a small number. And in terms of money, this would be a small number. That is my answer. Sweet. So that is how, there, let's come back. Boop. Yabam! That is how scientific notation works. One little thing that I wanted to keep in mind that I told some of you, but I forgot to tell most of you. It's not crucial, but it's just a little thing. When you're dealing with scientific notation, the exponent has to be a whole number. So you can't have like 1.3 times 10 to the negative 3.78. That's not proper scientific notation. Proper scientific notation says that the exponent has to be a whole number. Cool. From there, we got into graphing. Big key things to remember for graphing were, let's see, what do I got here? Oh, right, you got your x-axis is where you find the independent variable. That's the one that you have control over. And on the y-axis, the vertical axis, you have the dependent variable. That's the one that changes. You don't have control over that one. And the ways that you can remember that are Dixie with a smile. Here, let me see if I can do this here. Where'd my chalk go? There we go. Okay, right here. Let's try this. Dixie with a smile, right? Hopefully that's not backwards for you, because it's backwards for me, but I think it's forwards for you, because this part down here is backwards for me too. Anyway, Dixie with a smile works because the dependent variable goes on the y-axis, and the independent variable goes on the x-axis. The other one that I learned today that I thought was pretty cool was dry mix, right? Dry mix. That works because the dependent variable, again, goes on the y-axis, and the independent variable goes on the x-axis. So remembering one of those two things is a pretty good idea. That's going to help you when it comes to some of these questions. So there you have it. That's graphing. That's about it. That's what we talked about. Next week, we're going to get into classification of matter and physical versus chemical changes. And we're going to look at one demonstration that showed up on the Regents last year and kind of messed everybody up because they didn't know what the heck it was talking about. So we're going to actually see that demonstration in case it pops up again on a test. Some friendly reminders. If you have forgotten to turn in your lab agreement, please get that signed and turn in as soon as possible. At some point, you may want to visit or use the course webpage through the school, right? Go to the school's webpage, go to our schools, high school, and then staff, and then my name, and then maybe bookmark that, because there's a lot of really good information that you can find there. And then, oh, right, with the math pretest that you took, please be sure to take the student reflection survey by the end of the school day on Wednesday the 24th. That's going to count as a homework grade. You fill the survey out completely, you get a 100 on your homework. You don't fill it out, you get a 0. If you were not here to take the pretest, we'll talk about that later. Otherwise, I think that's it. Oh, you can find the survey by going to Twitter or the school's webpage or Facebook, and it's a link to the Google Drive there. So that's what's happening. So I guess what I'll say, I'm about to sign off here, stop going live. But thank you for tuning in if you watched, which I have no viewers right now, so that's cool. Then what I'll say is, if you're watching this pre-recorded, if you have any questions about this or anything else, please feel free to email me at rbray@windsor-csd.org. You can always email me with any questions you have there. So with that, thank you very much. I hope you had a great week. I hope you have a wonderful weekend. Good luck to all your adventures and things that you're going for, and I'll see you back Monday. Bye, everybody.